right, our last section for the entire year, section 13.5. Get excited! Permutations and combinations. So our last objectives are to use the formulas. There are two for the number of permutations and the number of combinations. So our essential question, how can a tree diagram help you visualize the number of ways in which two or more events can occur? All right, let's learn some vocabulary. So permutations is our first vocabulary word, and it's an arrangement of objects in which order is important. This is bolded and highlighted and underlined. For instance, the 6 possible permutations of the letters A, B, and C are shown. Well, I could arrange those 3 letters as A, B, C. I could also rearrange and say A, C, then B, or I could do B, then A, then C, and so on. So there are 6 possible permutations of the letters A, B, and C. All right, let's consider the number of permutations of the letters in the word July. How many ways can you arrange part A, all of the letters, and then we'll look at part B, 2 of the letters. So let's just first consider all of the letters. Well, let's use the fundamental counting principle to find the number of permutations of the letters in the word July. Now the fundamental counting principle, it's just an event that can occur in m number of ways. In other words, it's an unknown number of ways. And another event can occur in n number of ways. So it's just a different number of ways. Then the number of ways that both events can occur is m times n. So these two numbers multiplied together. So in general, we would look at number of permutations, so order matters, choices for the first letter times choices for the second letter times choices for our third letter times choices for our fourth letter. Well, we know if we place a letter in the first position, we've got 4 letters to choose from. Well, then we've chosen one of the letters, so now we're down to 3 letters that we could choose from for the second position. And then once we've chosen that letter, we then have 2 letters remaining for the third position. And then once we've gotten down to the final position, there's only 1 letter we could possibly choose. So if we multiply all those number of values together, we get 4 times 3 times 2 times 1, which comes out to be 24. So there are 24 ways you could possibly arrange all the letters in the word July. So now let's consider how many different ways we could arrange just 2 of the letters. And if we're arranging just 2 of the letters, you have 4 choices for the first letter and 3 choices for the second letter. So it's just 4 times 3. And that would be 12 ways you could possibly arrange 2 of the letters in the word July. All right, in example 1a, you evaluated the expression 4 times 3 times 2 times 1. We actually have a special name for that. This expression can be written in short 4 with an exclamation point. So it's like you shout the number 4. 4! Just kidding. That exclamation actually represents a special name in math. It's called factorial. So we read it as 4, and then exclamation, you read it as the word factorial. So we say 4 factorial. Factorials are any positive integer n in which the product of the integers from 1 to n is written as the following. So when I'm finding some number factorial, that's the same as that number n times the value minus 1 times the value minus 2 times and so on until you get down to the 3, the 2, the 1. So I think factorials were someone's attempt to make math look exciting. Heck yeah. We need math to be looking exciting with those exclamation points. All right, so we've got a core concept here. In example 1b, you found the permutations of 4 objects taken 2 at a time. So with the word July, we had 4 letters that we could choose from, but we only wanted the first 2 positions. So it was taking 2 at a time. So you can find permutations using the following formulas. If you want the number of permutations of n number of objects, it's given by, and we use the capital P for permutations. Notice the subscripts. You've got a number in the front of that capital P, and you've got a number in the behind the capital P. and they're the same value. And that's equal to our n value factorial. So, an example. You have the number of permutations being 4 objects, as in the word July. So we want 4 objects, which is going to equal 4 factorial. In other words, 4 times 3 times 2 times 1. Multiply that out together to equal 24. You also have the number of permutations of n objects taken r at a time, where r is less than equal to the number n. And it's given by this formula. So again, capital P representing permutations, and then subscript n in the front, subscript r after the capital P. And this is going to be a ratio. Take that n factorial divided by n minus the r value factorial. So this is the second example that we looked at previously. So the number of permutations of 4 objects taken 2 at a time. So the 4 is in the front, 2's in the is after the capital P. And that means you're doing 4 factorial divided by 4 minus 2 factorial. So if you write it out, expand it, you get 4 times 3 times 2 factorial divided by 2 factorial. And then in the denominator, you'll have 2 factorial, because 4 minus 2 is 2, and then the factorial. And when you have common factorials in the numerator and denominator, you can cross those out, and that will leave you with 4 times 3, which is 12. All right, so let's take a look at example 2, where we can use our permutation formula. There's 10 horses running in a race, and how many different ways can the horses finish first, second, and third? And assume there's no ties. So first, you're looking at finding the permutation of 3 horses chosen from 10. So to start off, you're going to set up your permutation notation, which is 10 capital P 3. Which means it's 10 factorial divided by 10 minus 3. And then once you have your setup, work out the denominator to be simplified, in this case 10 minus 3, which is 7. So you have 10 factorial divided by 7 factorial. Expand, so that's 10 times 9 times 8 times 7. You can stop at the 7 in the numerator because you want it. You can just divide out the 7 factorial in the numerator with the 7 factorial in the denominator. And that leaves you with 10 times 9 times 8, which is 720. So there are 720 ways for the horses to finish first, second, and third. That's a lot. All right, let's find probability using permutations for a town parade. You'll ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. So find the probability that your float is first and the float with the school chorus is second. Okay, so step 1, write the number of possible outcomes as the number of permutations of the 12 floats in the parade. So you've got 12 given 12, so that's just 12 factorial. Write the number of favorable outcomes as the number of permutations of the other floats, given that the soccer team is first and the chorus is second. So this is 10 permutations, so in other words 10 factorial. Find the probability, so the soccer team being first, chorus being second would be 10 factorial divided by 12 factorial. So that's going to be 10 factorial divided by, and then 12, 11, 10. You can stop at the 10 because the 10 factorials will cross out and divide each other out to be ones. So you have a 1 in 132 chance that the first float is the soccer team and the chorus is the second. All right, let's learn about combinations. Combination is selecting objects in which order is not important. For instance, in drawing for 3 identical prizes, you would use combinations because order of the winners would not matter. If the prizes were different, then you would use permutations because the order would matter. But if the prizes don't matter, then the order of the prizes and winners does not matter, so you would do combinations. So let's take a look at an example. Counting combinations. Let's count the possible combinations of 2 letters chosen from the list A, B, C, and D. So list all the permutations of 2 letters from the list A, B, C, and D. Because order is not important in a combination, cross out any duplicate pairs. So let's take a look at our possible pairs. We have all these different combinations. Well, B and D or D and B are the same pair. And then the CA, the CB, the DA, the BA, the DC. So there are 6 possible combinations of 2 letters from the list A, B, C, and D. So this leads us to a formula for combinations. The number of combinations of n objects taken r at a time, where r is less than or equal to n, can be given by, now we're dealing with a capital C for combinations, and then n is the number of objects, and then r is the taken number. So given n objects taking r objects. So this time, it looks real similar to permutations. You've got the n factorial in the numerator, so that's the same. But the denominator has a little extra information there. So same as permutations with the n minus r parentheses factorial. But then in combinations, we're going to multiply an extra value, the r factorial value. So let's look at this example. Number of combinations of 4 objects taken 2 at a time. So 4 and then 2. So 4 factorial divided by 4 minus 2 factorial times 2 factorial. Again, expand your 4 in the numerator. So 4, 3, 2. You can stop at the 2 because 4 minus 2 in the denominator simplifies to 2 factorial, and those 2's can divide each other out. That leaves you with this 2 factorial, which is 2 times 1. So you have 4 times 3, which is 12, divided by 2 times 1, which is 2, which simplifies to 6. Alright, so let's use our combination formula. You order a sandwich at a restaurant, you can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? So the order in which you choose the side dishes is not important. So to find the number of combinations of 8 side dishes taken 2 at a time, that would be find given r combinations taking 2. So set up your formula, starting off, so 8 factorial divided by 8 minus 2 factorial times 2 factorial. Simplify what's in parentheses to be 6 factorial. Make sure you expand in the numerator, so 8 times 7 times 6. You can stop at 6 because the 6 will cross out with the 6 in the denominator. And then the 2 factorial needs to be expanded to 2 times 1. Alright, so then 8 times 7 in the numerator would be 56 divided by the 2, which is a result of 28. So there are 28 different combinations of side dishes you can order. Alright, our last example, a yearbook editor has selected 14 photos, including one of you and your friend, to use in a collage for the yearbook. The photos are placed at random. There's room for 2 photos at the top of the page. What's the probability that your photo and your friend's photo are the 2 placed at the top of the page? So step 1, write the number of possible outcomes as the number of combinations of 14 photos taken 2 at a time. So that would be 14 combinations given taking 2. So because the order in which the photos are chosen is not important, we will be using combination. So set up your formula for combinations. So 14, choose 2. So that's going to equal 14 factorial divided by 14 minus 2 factorial times 2 factorial. Again, simplify what's in parentheses, so that simplifies to 12. Expand your 14 factorial in the numerator. You can stop at the 12 because the 12 factorials will cross each other out. Expand your 2 factorial to be 2 times 1. So 14 times 13 in the numerator divided by 2 times 1 in the denominator will simplify to 91. Step 2. Find the number of favorable outcomes. Only one of the possible combination includes your photo and your friend's photo. And then find the probability. So you want the probability that your photo and your friend's photos are chosen. So that's a 1 in 91 chance. Alright, I'll leave you with this exciting cartoon for our last video. There is one more page of notes which explains how to use the calculator to practice all of these skills using your probability feature on the TI Inspire. So make sure you read through those instructions, try the examples through the notes again, learning the features in the calculator, and we'll practice in class tomorrow. See you then.